All right, let's jump right in. Look, if you've ever tried to track political news for, any serious reason, it's just a total fire hose of information. It's overwhelming. So today, we're going to break down a tool that's designed to fix exactly that, taking all that chaos from news feeds and turning it into clean, structured data that a machine can actually understand.
And really, this gets to the heart of the problem, doesn't it? A simple stream of article links, it's just not going to cut it. It's so noisy, it's super repetitive, and trying to automate anything with it, forget about it. You end up manually sifting through like a dozen headlines that are all basically saying the exact same thing. It's a huge waste of time, and worse, you might actually miss the important stuff, the real signal in all that noise.
So what's the alternative here? Let's just look at this side by side. You've got your standard RSS or Google News feeds on the left, and yeah, they're fine for just browsing, but for any real work, they're missing everything. No deduplication, no way to cluster related stories, and definitely no change detection. Now look at the right. That's the goal. A system that does all that for you, groups the articles, figures out what's new, and wraps it all up in structured JSON.
This really brings us to the core idea, which is a pretty fundamental shift in how you think about this stuff. We've got to stop tracking individual articles and start tracking the actual events that they're all talking about.
And what's so cool about this is how it reframes the whole process. You see, tracking articles, that's optimized for humans. It's messy, full of the same information over and over. But tracking events? Well, that's optimized for machines. The data is structured, it changes and grows as the story develops, and it's built from the ground up for production workflows. This isn't just another discovery feed, it's a true transformation layer.
So how does this all happen? How does that transformation from noise to signal actually work? Let's put on our system architect hats for a minute and take a peek under the hood at the data pipeline.
Okay, so from an architectural standpoint, here's the flow. It all begins with the sources. Your typical RSS feeds, Google News queries, that kind of thing. The first stage gate is normalization. This is pure data hygiene. We're cleaning up URLs, shaping metadata into a consistent schema. Next, and this is where the real magic happens, is clustering. We're using deterministic heuristics, smart, rule-based groupings, to collapse all those duplicate reports into a single event entity. Then we hit change detection. Here, the system uses persistent fingerprints. It hashes the core data of an event, and by checking against its state store, it knows definitively if this is a new event or just an update to an existing one. And finally, delivery. The processed, structured event object is emitted to a dataset and can kick off any downstream notifications or workflows.
Right, that's the theory, the architecture. But what does this actually look like in the real world? Let's walk through a couple of use cases to see how powerful this becomes when you're actually monitoring events.
First up, let's talk about sanctions monitoring. This is a classic headache for anyone in risk intelligence or finance. One single announcement can set off a massive wave of news coverage from every conceivable angle. So, picture this. The US Treasury announces new sanctions. Okay, so you get a bunch of articles about that. But then, almost immediately, you get another wave of stories about how EU diplomats are reacting. Then the market analysts start weighing in on the financial impact, and then you see reports that the targeted company's stock is tanking. A human knows these are all connected, right? But to a basic feed reader, these are just 4 totally separate links. And here's the payoff. The clustering engine is smart enough to see that these are all just different angles on the same core event. So it collapses them all into one single evolving event object. That object gets a stable ID that you can track over time, and, this is key, it keeps a full list of citations for every single source article that contributed to it. Just like that, the noise is gone. All you have left is a clean, unified record of what actually happened.
Okay, let's try another one. Tracking an election. Now, unlike a sanction announcement that happens at one point in time, an election is this long, drawn-out story that unfolds over weeks and months.
This is where that idea of an evolving event object really becomes a game changer. An event isn't static, right? For an election, you might create a single event object the day a candidate announces they're running. But then, over time, that same object gets updated again and again with new info. Polling data comes in, debate highlights are published, policy positions are announced, and then finally, the results. The change detection feature makes sure your system only sees the meaningful updates, not every single repetitive headline along the way.
And that brings us to a really crucial point. This entire system isn't really designed for human eyeballs. It's built to be plugged directly into other machines, into production systems, whether that's an automation pipeline or a sophisticated AI model.
And you can see that optimization plain as day in the output. This is not meant for you to read, it's meant for code to parse. You get a stable event ID so your system isn't wasting time reprocessing stuff it's already seen. You get these clean, compact summaries and automatically extracted entities. The people, the organizations, the locations involved. You can just feed this data directly into another model or a database. It's all signal, no noise.
Now, anybody who's ever run a data pipeline at scale knows the elephant in the room is always cost. You can have the best data in the world, but if processing it is going to break the bank, it's just not viable.
And listen, this is a huge differentiator. The core engine here, the clustering, the summarization, it all works without forcing you to make mandatory and frankly very expensive calls to external large language models. You're not constantly hitting OpenAI or Anthropic and just watching your bill skyrocket. This whole approach keeps costs way down, which makes it actually practical for the kind of high-volume, continuous monitoring we're talking about.
And finally, we have to talk about trust and being able to audit your data. Especially now, in the age of AI. If you're going to feed this data into another system, you have to be able to trace it back to its source.
This is absolutely critical if you're building AI apps, especially with something like a retrieval-augmented generation, or a RAG pipeline. Because every single event object contains full source citations, you always know exactly which articles were used to create the summary. The source URLs, the metadata, it's all preserved. This gives you a direct audit trail, and it prevents the kind of hallucinated or just plain made-up content that can really plague AI systems. It is trustworthy by design, because it's grounded in its sources.
So as we wrap this up, I think it all comes down to this one question. Is the system you're building just reacting to the endless noise of headlines, or is it intelligently tracking the real underlying events as they actually change and evolve? Because that difference, well, that's everything.